Hello students, I am Bhumica Verma, Assistant Professor CSC Department in Akgec Engineering College, and today the topic of my lecture is Introduction to Machine Learning, which is one of the topic in the course of AKTU, that is Machine Learning Techniques, having the code BCS055. So this is the detailed syllabus of AKTU as per 5th semester in AKTU for MLT. So these are the topic I am going to discuss in my lecture. So first of all, what is machine learning? So according to Herbert Simon, learning denotes the change in the system that enables a system to do the same task again and again, but more efficiently when it is done in the next time. So machine learning is basically the learning of the machine, in which the machine is going to learn something. As per the learning of the human, when we do something again and again, then the learning is efficiently increased in the next step. Similarly, the machine is forced to learn something in one instance, and then it is again forced to do the same thing again and again, but it was done efficiently as the human does. So as per the scenario of today's world, or the scenario of the digital era, machine learning is lying between the artificial intelligence and the deep learning. So you can say that machine learning is a subset to artificial intelligence, and it was the superset for deep learning. So we need to know that what exactly is AI and what exactly is deep learning, so that we can easily understand machine learning is. So in terms of Arthur Samuel, it is a field of study that gives the computers the ability to learn from the data without being explicitly programmed. So as per artificial intelligence, in this today's world, artificial intelligence of composed of two words, that is artificial as well as intelligence. Artificial means that is man-made, and intelligence means the thinking power. Therefore, AI is meant to be man-made thinking power. Therefore, we can say that AI is a branch of computer science by which we can create intelligent machine which can behave like human, think like human, and able to make decisions as well. So AI exists when the machine is can have the human based skills such as learning, reasoning, and solving problems. So in today's world, in today's fast growing technology, we are getting in touch with different new technologies day by day. So there is an essential need for this branch, that is AI, which is ready to create a new revolution in the world of making intelligent machine. So that is why it is termed as a superset for machine learning. Therefore, we can say with the help of AI, we can create personal virtual assistants as well as like a Cortana, Siri, Google Assistant as well. It opens a path for the new technology and the new devices and some kind of new opportunities as well. So it can build robots, it can build a new environment, and it will create an environment like that will be survival for the human that can be at risk. So AI is the one branch. AI is the branch, or AI is a field, you can say, that can create various kind of software or the devices which can solve real world problem very easily, very accurately. That can be triggered in the field of health and marketing, as well as also being implemented in some traffical areas. So AI is one of the emerging field. Then what is deep learning? So as the name indicates, as the figure also says, that deep learning is somehow learning by deep by nature. That means we are learning something in layers, that means one by one or one over the other. So this is one of the picture that denote the same thing, that the learning is being done in some parallelly, but they are also being done concurrently. So that means if we are learning in one layer, then again this learning is being refined and it is done again, then again, and then the output is being delivered. So you can say that input layer is also having some kind of learning in between, some kind of patterns and some kind of local contract in between. Some kind of features is being embedded in the hidden layer, then again some features are embedded into this. After all the refinements are done, and then the output layer will produce the output for the same. So deep learning is based on the branch of machine learning, which is a subset for the AI. So it is based on the idea, or it is based on the principle of neural network. As the human neural networks are working, that means neural network actually imitate the human brain. So deep learning will also act or also principally work on the same principle. So it is programmed explicitly. Basically, it is a machine learning class that makes the use of various non-linear processing units so that it will perform the feature extraction as well as the transformation. So deep learning is one of that part. So what is machine learning? After knowing that what is AI and what is deep learning, so after all these things, the machine learning is a subset for AI that enables the computer to automatically learn from the patterns, make predictions, and execute tasks with minimum human intervention. So ML is involved in the dynamic field with every kind of potential that reshape the industries and change the way we approach the problem solving. Why it is important? This is important because in the today's world that is having the vast amount of data, that is having the huge amount of data, volume of data. So that volume, that vast amount of data can be quickly generated and quickly accessed. That needs to be accessed because to generate the insight as well as the prediction out of it, so that we can get the most of the data, or you can say the insights of that data. So it allows the innovations in the industries to be done. It will be range from the healthcare to finance or some organization, in any kind of organization, to improve the decision making abilities and also improvising the human experience, as well as it will improve the development of the new products. So machine learning is that branch that enables the system to learn from the data, identify the pattern, make the decisions. Minimum human intervention will be required. It involves any kind of training algorithm on the large data set so that it can improve the overall performance over that period of time. So the application towards it could be predictive analysis, speech or image recognition, recommendation systems, and also many more, which will be discussed in the further slide as well. So when I say about machine learning, that means machine is learning. That so that means there should be some kind of programming where machine is not learning. So that there might be two comparison, that what is machine learning and what is traditional programming. So when I contrast all these two terms, so this picture depicts the same scenario, what a traditional programming is, in which the data is being fed into some kind of software or some kind of application. Some program is being developed and somehow the output will be delivered in that case. So this is a traditional programming. But when I talk about machine learning, in which the data is being fed into some kind of software, but in kind of some algorithm, and that algorithm must be created somehow to create a model or to put an hypothesis on which those hypotheses, the data will be fed again and again. The training will be done on this hypothesis, and somehow the output will be delivered. So the data whose output need to be predicted, that should be fed into this model, and this model will give me the predicted output. So this is the difference between the both, the traditional programming as well as the machine learning. So the machine learning is basically the using of data for answering any kind of question. For using this data, we need to train something. For using the data, we need a data set. That data set is being divided into two parts, that means training and testing. So some part of that data set will be used for training, and we will use that data for training purpose only. And after using that particular data for that training, we'll use the another half of the data for the making the prediction or for the testing purpose. So for using the data, we need to train something, and for answering the question, we need the prediction on the second half of the data set. So these are the precise definition given by the Arthur Samuel in 1959 and Tom Miguel in 1997, which all about says that the computer program is said to learn from the experience E with respect to some class of tasks and performance measures P. At these tasks, it is measured by P, which improves the experience E, which I have already discussed, that there are three scenarios: then experience, the task, and the performance. Every time when the experience is increased, the number of tasks is increased, the performance also increased. So these are the three parameters we are going to discuss in the next topic, what we say that the well-defined learning problem. So what kind of machine learning problems it is applicable in. So the problem where there is no deterministic algorithm, or you can say we can recognize the 3D object from the given scene, where the solution for the individual specific problem is time dependent, that is in the case of recommendation system, or you can say the targeted advertisements, where the prediction based or the past or the existing patterns need to be identified. That means we need to do the prediction for the share prices, etc. Then the problems which do not have the fixed solution or the goals posed keep changing. Such kind of system adapts the learn from the experience, like spam emails, financial fraud, IT security framework. So these are the problem where the ML is applicable. There are some more also application area we'll discuss further. So the machine learning work is done in some crucial steps. These are the crucial steps, that is data driven approach, data collection and pre-processing, feature selection and engineering, training and testing of the model. So data driven approach is basically relies on the collection of the data. After collecting all these data, we make the initial phases of the data collection processing. So in this second stage, the data is being collected and the data is being pre-processed. Collection is the collecting of the data from various sources in numerous number of formats, and huge number of data will be there, and will gather all these data accurately whatsoever we are getting it from any of the sources. Then in the second part of the second step is the pre-processing, that once we collect the data must be clean and the formations or formatting will be done, as the raw data contains various kinds of inconsistencies and various kind of impurities or irrelevant data, or some kind of blanks are also there. Some fields are null, some fields are unformatted, some fields are not related, some field is extraordinary large. So we need to refine or tune down those fields. All these things what we done for doing all these things needs to be known as pre-processing. That means we need to filter out that data, we need to tune down the data, we need to clean that data, so that we can use that data particularly in the next section, that is feature selection. So feature engineering involves the selecting of the essential data features from the data set that we have cleaned in the previous step. We will reduce that data set into the some selected features that we require to train our model, so that it will reduce the data noise or it will enhance the model performance. Thirdly and the lastly will be the training and the testing models, in which the data is being prepared. For this, a model is being trained on a portion of it to recognize some pattern. The remaining data, as I've told you, that remaining data will be reserved for the training purpose, testing purpose, and it allow the developers to evaluate how well the model will perform on the new or the unseen data. So half of the data in some kind of ratio like 80-20, 80% of the data will be used for the training purpose and the remaining 20 will be left for the testing purpose, or vice versa, or the ratio will be changed according to the scenario what we are going to model down, or what we want to create a model to for. So these are the type of machine learning. So there are 4 types of machine learning, that is supervised, unsupervised, semi-supervised and learning reinforcement learning. As the name suggests, the supervised learning is the model in which the model is being trained on the labeled data, where the learning is being done in supervision of someone, in which there will be known outputs. Example, we are predicting some kind of house prices, or we are detecting the spam in the emails, images being classified. So application to this learning will be the medical diagnostics, email filtering or fraud detection. The second is the unsupervised learning, in which the learning will be done in not in the supervision of any of the supervised person or some higher authority. That's in this the model will learn from the unlabeled data, finding the patterns on its own. So it is basically, the example says the market segmentation or the anomaly detection, or you can say the clustering of the customer data are the application towards it. Semi-supervised is the combination for supervised as well as non-supervised learning. That means partially labeled data will be there and unpartial labeled data will be there. So example towards it is the voice and the image recognition. The application for this will be the text processing, image classification, voice recognition. Reinforcement learning is the model in which model will learn by the environment itself by receiving rewards or penalties based on the action, and it will optimize the decision making over a period of time. So example we'll use in the robotics or autonomous driving, or we are using the AI in the games. So application for this will be the same. That means advancement in the gaming strategies in which the model will learn from the environment by some kinds of factors, like it is getting rewards, it will get penalty. So autonomous vehicles will also the application for the same. Then after learning all these things, the learning term which was introduced in the first slide, that learning is the learning or adapting of something from the environment, but it will increase the efficiently over a period of time. So now this learning is being precisely cleared through ML, that what learning actually is in terms of ML. So in as per definition, the computer program is said to learn from the experience E. In particular scenario, it will be experience E with respect to some class of task T, and some performance measures will be there which will be termed as P. So all in all, if its performance at a task T as measured by P improves the experience E, the same thing which I have told in the previous slide also, that the performance will be increased as the T is increased, and if T and P both are increasing, then the experience E is also increasing. So this is what learning is. The machine also learn in the same way as we are learning in the scenario, that we are learning something from the environment for the period of time, or over a course of time we will learn by our experience, by the performance we do. So in the same way the machine also learn the same. The performance is increased as per the number of tasks is increased. As the performance and the task is increasing, the experience is also increasing. So one of the example is handwriting recognition problem, learning problem, in which the task is to recognize and classifying the handwritten words within the image. So here the performance P parameters are the percent of words that are correctly classified. So in this, the training experience will be the data set will be given of handwritten words with given classifications. So these are the three learning parameters that needs to embed into the training model. Similarly, the next example will be the robot driving learning problem. In this, the task will be driving on the highways using the vision sensors. The performance measure will be the average distance traveled by the car or the person who are driving, either the AI bot or you can say the human, before an error. So this is a performance measure. Experience will be the sequence of images and the steering commands recorded while observing the human driver. So these are the three parameters that needs to be embedded into the machine. Similarly, for the chess learning problem, playing chess is the task. Performing measures will be the percent number of games it will be won against the opponents. The training experience will be playing practice of the games again and again against itself, and it will learn by its experience. So a computer program that learns from the experience is called a machine learning program, or simply a learning program. Such programs are sometimes referred to a learner. So these programs are referred to be a learner. So components of learning will be, like if we are learning something, that there are three parameters we have just discovered, that there will be three parameters, that is experience, that is task, that is performance measure. For all these purpose, we need some kind of components that needs to be embedded into a machine learning model. So it will be data storage, it will be the abstraction, it will be the generalization and evaluation. So data storage is basically the collection and the storage of anything, like any of the data set that is being stored into the model. So in this case, what I say is data storage. All those facilities that are storing and retrieving the huge amount of data is important component of the learning process. So human computers alike utilize data storage as a foundation for advanced reasoning. In this, the computer use the hard disk drivers, flash memory, random access memory, or some similar devices to store the data, or also uses cable or some other technology to retrieve those data. In case of abstraction, as the name indicates, the second component says that we are extracting the knowledge. We are only extracting that knowledge that is essential for creating the general concepts, like extracting the knowledge about the stored data, This involves the creating of general concept about the data as a whole. The creation of knowledge involves the application of the known models and the creation of the new model. So the process of fitting a model into the data set is also known as training. When the model is being trained, the data is transformed into the abstract form that summarizes the original information. So abstraction is basically the abstracting, or taking out the essential information that is required from the dataset from the storage for which we require to train our model. So abstraction is that part. Then generalization is the third component of the learning system, known as generalization, which describe the process of turning the knowledge about the stored data into a form that can be utilized in the future action. These actions are carried out on the tasks that are similar but identical to those that have been seen before. In generalization, the goal is to discover those properties of the data which will be the most that will be the most relevant in the future task. Lastly will be the evaluation. Evaluation is the last component, which says the process of giving feedbacks to something. It is the process of giving feedback to the user to measure the utility of the learned knowledge. That means we are gauging something, that what we have learned will be checked, will be evaluated with the help of feedbacks, that what we have learned will be good enough to go further or not. So it is a kind of feedback for the user to measure the utility of the learned knowledge. So this is a feedback we utilize to improvise, to effect the improvements or the nature of the experiences. So it affects the improvements in the whole learning process. So this is a process of evaluation. So what are the benefits of machine learning? As per this lecture, we can say that it is enhancing the efficiency and the automation. It improves the accuracy and the decision making capabilities of a machine. So if it is having some benefits, so there might be some challenges and limitations also. So the limitation is the data privacy and the security concern, as the machine learning involves prominent and sensitive industrial areas and some industrial issues. So it creates some issues of privacy and security as well. The requirement of large data set will always be the substantial issue in achieving the accuracy. And so this is a challenge in the data scarce field. Model interpretability is the third challenge, which says that the understanding the complex model will be challenging, especially when the decision needs to be justified. So model needs to be interpretable in this case. So these are the application area in the last term, in the last slide, that says that what is machine learning, why it is important, what kind of machine learning we have learned today. So these are the application area where the machine learning is applicable nowadays, that is healthcare, finance, transportation, manufacturing, education, agriculture, entertainment, and energy, security and surveillance. And these are various examples toward it, that where it is being used nowadays, that is crop monitoring, adaptive learning platform, defect detections, self-driving cars, personalized recommendation, dynamic precising, stock predictions, stock management, credit scoring, medical image analysis, and you can say that smart grid management, consumption prediction, energy efficiency. In security and surveillance, you can say the application might be intrusion detection, CCTV monitoring, and access control. So these are the further dominant and the emerging application area with their examples on the other hand. So these are the basic term to the machine learning, and these are basically the introduction towards the machine learning. In the next lecture, I'm going to discuss the types of types of machine learning in detail. So till now, I hope the introduction to machine learning is clear. Thanks for listening the lecture.